Hello, welcome to Calculus. I'm Quillen, and today we're going to be taking one last review of limits and all of the ideas that come along with graphical analysis of limits. So I have gone ahead and drawn 4 graphs on the screen for you. They're a little bit tangled in this section right here and in this section right here, but I have color coded them for ease of understanding. So, if you are colorblind, I will be doing my best to remember to trace along the graph so that you can tell which I'm talking about. I have forgotten to do that in past videos, and I apologize. So, first, let's talk about this green graph. So, it goes from over here and it follows down, scoops, and then asymptotes up. Let's call that at positive 10 rather, and then has another vertical asymptote on the other side at 10 coming from negative, and then going off and doing whatever off our screen. Excuse me. So, first I want you to find the left-handed asymptote, or rather the left-handed limit as x approaches 10 of this green. I'll give you a second to do that now. I hope that you pause the video to think about what exactly that implies and that you were able to come up with the answer that the limit as the green graph approaches 10 is infinity. And the estimation for that follows this logic. You're tracing the green graph and you see that as it's getting closer and closer and closer to 10, the value seems to just be going up and up and up and up. And it doesn't seem like it's going to stop anytime soon. And you don't ever see it cross 10, so you don't know what the value is at 10. So you can't use that to inform your decision either. Now, I want you to find the same limit from the right-hand side. So, what is the right-hand limit as x approaches 10 of this green function? I'll give you a second to think about that now. Okay, I hope that you paused to think about it and that you found that the best estimation is that the limit on the right-hand side as this green graph approaches 10 is negative infinity, because it tracing from the positive side towards the negative side, you approach 10 and the graph seems to just be going down and down and down forever. You don't ever see what it equals at 10 from that side, so you can't use that to inform your decision. It's the exact same logic that we used for the left-hand limit. Now, I want you to pause and find the limit as x approaches 10 of this green function. No left hand, no right hand, just the limit. Okay, I hope you decided that the limit does not exist. The reason that the limit does not exist is because from one side, the limit approaches infinity, and on the other side, that limit is negative infinity. Positive infinity and negative infinity, of course, do not equal each other, and therefore, this limit cannot exist. Because remember, limits only exist if both the left and right hand limits at that same point of that same function are equivalent. Now, let's talk about this pink graph. So it comes in over here, closer to the axes, and then goes up. There's a little hole at about 0.6, and then it comes back down and goes back to probably oscillating some more. I want you to find the left hand, right hand, and plane limit as x approaches 0 of that pink graph. I'll give you some time. Okay, welcome back. I hope that you paused and found the following answers. The left hand limit is 6, the right hand limit is 6, and the plane limit is 6. Let's think about why each of those are. Coming from the left-hand side, that is the negative side, we're tracing along the graph, and we can see that if there was not a hole here, the graph would probably be 6. And that is what that value gets closer and closer to. If we were to zoom in on that graph, we would see that it looks like it's going to be 6. The same logic applies coming from the right-hand side. As we come from the right, the graph traces and it gets closer and closer to 6. And because it seems to get closer and closer to 6 as x approaches 0, we can conclude, therefore, that the limit is 6. Now, because 6 and 6 are equivalent, they're the same number, we can conclude that the limit as x approaches 0 of this pink function is 6, and that is only because the left and right hand limits are the same. Now, look at this purple line right here. It might be the hardest to see. It starts up here, comes down, dips, and then comes right back up for just a bit, and it continues going down. For this purple graph, I want you to find both unbounded limits. And again, you're just estimating because you don't have enough information to tell a full story. All right, welcome back. Let's think about both of those questions. So let's start with x approaching negative infinity. So start at 0 and trace along here. You don't have to start at 0. You can start at any point left of where you are left of the last point you have, because we are saying x is approaching negative infinity, or any point to the right is what I should have said. You want to start as close as possible in your actual math practice so that you don't waste time and so that you are really thinking about correctly what a limit is. But this is a good way. Starting further away, in my opinion, helps strengthen some skills. So starting at 0 and tracing this purple graph, it seems like as x goes to negative infinity, this is just going to go up and up and up forever. So that means as x approaches negative infinity, this function approaches positive infinity. Connecting end behavior to unbounded limits from our past video, we can therefore conclude that the limit as x approaches negative infinity of this purple graph is positive infinity. Let's now go the other way. So starting at 0 again, although you could start closer or further away, and tracing in the positive direction this time, it seems like y is going to go down and down as x approaches positive infinity. We don't have enough information to conclude whether or not it will asymptote, but based on this estimation, it looks like it's just going to go down and down and down. Therefore, connecting end behavior and limits, as x approaches positive infinity, y seems to approach negative infinity. Therefore, the limit as x approaches positive infinity of this purple function can be estimated at negative infinity. I've been saying equals or is these videos, although technically, when you only have a graph and not a numerical representation or an algebraic representation of a function, you cannot conclude with certainty what the limit equals. You can only estimate. Finally, let's look at this red graph. So starts at the axis and it goes up, it asymptotes at x equals 3, and then there's a hole at x equals 3, and then it comes back from the axis and goes down. So I want you to combine all of your skills to think about this red graph. Think about the limit as x approaches 3, right-handed, left-handed, and plane. And then also, I want you to find both unbounded limits. I'll give you some time to do that. All right. Hopefully, you paused the video and found some answers. Let's start with the unbounded limits. Coming from here and tracing, it seems like as x goes to negative infinity, this will just continue going down. Again, we don't have all of the information, but we can conclude based on what we have that this will just keep going down. Therefore, we can say that the limit as x approaches negative infinity of this red function is negative infinity. Let's do the same thing for the other unbounded limit. We trace this line, and it seems to just go down and down and down. Because we don't have any evidence that it will oscillate, we can conclude that it will approach negative infinity. Therefore, the limit as x approaches positive infinity of this red function is negative infinity. Now let's think about those one-sided limits at x approaching 3. Let's start from the left. As x approaches 3 from the left, it asymptotes. So it just goes up to positive infinity on the y-axis as x gets closer and closer to 3. Therefore, the limit of this red function as x approaches 3 is positive infinity, we can estimate. Coming from the right-hand side, though, as we trace and get closer to 3, it seems to get very close to 0, and we can estimate that it will be 0. Therefore, the right-hand limit as x approaches 3 of this red function is 0. Now, the limit plane as x approaches 3 of this red function, what's that? Well, positive infinity on one side, 0 on the other side. Positive infinity and 0 do not equal each other. Therefore, the limit as x approaches 3 of this red function does not exist. I hope that you found this video helpful, and I hope that you will continue with me on this journey through calculus. Tomorrow, we will start our next topic, which will be a new look at limits, and we may even talk about continuity. I hope you'll join me. This is Quillen signing off.